Okay, so next up, epoch timestamps. So this is where you can convert an integer or a float to a time. So if we just run through this quickly, you can see that if we can try to convert an integer value to a date time, it will give us January 1st, 1970 at midnight. And so if we convert 1 to a date time object, this is 1 nanosecond. So this is a standard way to represent dates as just integers or even floating point values. You can do decimals of nanoseconds, but and so you can see that 3 billion nanoseconds is 3 seconds, and you can kind of knock yourself out here. So here we're showing units equals seconds, so it's only showing us the seconds, but it's represented under the hood as nanoseconds. In this case, we can set the unit as milliseconds. So typically, oftentimes the way you'll use these time series data is as an index. So we saw there's a basic way to create an index using this date time, using a list of these date time or timestamp objects. So we can either take that list of timestamps and make a date time index with it, or we can use this pd.index function, and it will automatically convert those to it'll automatically recognize that that's a date time index. However, this is cumbersome because we often will have many values. We don't want to have to enter them individually. We want a function that will kind of generate regular intervals, for example. So we have a function called DateRange and a similar function called bDateRange, where the B stands for business. And but we really only need DateRange. We can generate business dates even with that. So we need 3 pieces of information to generate a range of dates. We need either the start, the number of periods, and the frequency, or we need the start, an end, and a frequency. And from those, it can infer what it needs to. And the frequency is optional. If you don't put frequency, it will default to date, but it still is using that piece of information. And for bDateRange, the default is B. So if here we're generating a frequency equals M, so that M is month, we have 1,000 periods, and we're starting with March 1st, 2018. And by default, the month frequency will use the last day of the month as the date that it uses. But you can adjust that. So using frequency B instead of sorry, I'm gonna just I might readjust the order of these. But anyway, so if we do frequency equals B, this is business date as the frequency. So we're starting at March 1st, and then we're getting business days. So March 1st, March 2nd. This is this week actually. So Thursday, Friday, and then Saturday and Sunday are not shown, and then Monday, Tuesday, Wednesday, etc. But if we just want the default, this will give us every day. So this is probably more intuitive or more useful for scientific application. And I want to remove this. So by default, we don't need that frequency equals B for B date range because that's the default behavior. So we've seen a few of these aliases already. So we have day frequency. That's D. B is business day frequency. W is weekly. BW is business business weekly. Month business month weekly. And this MS would be a frequency of every month, but with the date starting at the beginning of the month instead of the end of the month. Annual frequency, minute frequency, etc. So just to give you some examples of these. So we're going to define two dates, T1 and T2. This will be our start and our end. So this is from January 1st, 2011 to January 1st, 2012. So if we do a range equals pd.DateRange start end frequency D, and then we look at that, it's a date time index of length 366, so that's right 1 year plus a day, and it's just a range from every single day. So very simple to generate that. You can also generate every week. So this would be, by default, every week defaults to Sunday as being the first day, but we can specify that explicitly here. So week beginning with Sunday. So now we're going to get that, we're using those same dates, but by creating a date range with a different frequency, we're only getting every week instead of every day. If we use B, we're going to get only business days. If we do BM, we're going to get only business months. So these are still, this is monthly, but using business days. So you can see that the last day of the month in this year was, okay, 31st, that's the last day of January, 28th, last day of February, 31st. But April has 30 days, but the last date here was the 29th because the 30th would have been Saturday. So it's able to calculate that. We can also specify the start would be just using the default, or sorry, we're using an end date and then working our way backward from the end of that year. So we can specify an end and then a number of periods, and then it will work its way backwards. Or we can specify a start and a number of periods, and it will work its way forwards. But this is using B date range, the same as possible with regular date range. So oftentimes, this is all how you would enter, one of the ways you can enter data to make a date range, but oftentimes if you import data to pandas and it recognizes that it's you know how when you import into pandas it will try to figure out the data types unless you specify. So it will see that column, it has dates and times in it, and it will automatically convert that to a date time object for you. So a lot of this are things that you might not even need to use often in practice, but it's important to know how they work. But in any case, with this date time index, there's a lot of things you can do. You can, for example, slice based on a set of dates or times. You can quickly access certain periods of data. So just to see a few of those examples, we're going to specify a start and end date. Again, this is using January 1st to end 2011 to January 1st, 2012. Or make a date range from start to end, frequency BM. And we're going to make a Panda series of random numbers using that index. So we have 12 values at the end of the last business day of each month. And so we can pull out the indexes just of those values. Well, this is effectively what we've seen before. So we're basically slicing this series to get the first 5 values and getting the index of those, or we can span get every other index. So one thing to point out is when we covered slicing before, we saw over and over that when we slice using a numerical index, we get the starting index up to but not including the end, right? So we have this sort of asymmetry that has a lot of benefits, but something you had to kind of get used to. Well, in pandas, and I haven't really emphasized this much, but in pandas, when you specify a label instead of a positional index, you get both sides. So so here's an example. So we're going to make a series which has this is what I wanted. Yeah. Hang on. I'm going to pause this because I think I made a typo here.